On October 4th, 2025, NASA's Perseverance rover captured something completely unexpected. One of its navigation cameras, normally used just to steer across the rugged Martian terrain, spotted a thin glowing streak cutting through the crimson sky above Jezero crater. It wasn't a glitch or a shooting star, it was the interstellar comet 3I Atlas blazing past Mars in a rare cosmic encounter. This wasn't supposed to happen. The NavCam isn't built for stargazing. It's a utility camera meant to help the rover navigate rocks, slopes, and sand. Yet on that night, it recorded an image so striking that NASA featured it as their image of the week. The streak looks eerily perfect, long, smooth, and symmetrical, almost like something designed, not natural. But here's where things get weird. The NavCam isn't meant to photograph distant objects. At the comet's distance, roughly 38 million kilometers from Mars, each pixel in that photo spans about 12,000 kilometers of space. That means the gluing stripe appears nearly 50,000 kilometers long, far larger than anything physically possible. Earlier data from NASA's Sphere-X mission capped the comet's real size at no more than 46 kilometers, assuming it reflects only a tiny fraction of sunlight. That's nearly 1,000 times smaller than what Perseverance's image seems to show. If 3I Atlas really were a 50,000 kilometer long cylinder, it would have looked absolutely massive in Hubble's July 2025 snapshots, stretching across nearly 23 arc-seconds of the sky.
3I Atlas has all kinds of surprises. We've only seen a handful of blurry shots that look like a tail is kind of starting to form. There's the unusual chemical signatures. It's producing way more nickel than iron, and scientists don't really know why.
But that's not what Hubble saw at all. Instead, it appeared as nothing more than a tiny, unresolved dot of light. That instantly ruled out the idea of a colossal structure. Whatever Perseverance saw, it wasn't real, at least not physically. The most logical explanation, motion blur. To capture something as faint and distant as an interstellar comet from Mars, Perseverance's imaging team had to stack hundreds of short exposures over several minutes. During that time, 3I Atlas drifted slightly across the Martian sky. The result, a stretched-out streak that looked like a glowing line slicing through space. While that image caused a storm on social media, the clearest version so far comes from a dedicated space enthusiast who processed the original mastcam data. The link's in the description if you want to check it out. And this wasn't just a one-camera show. Multiple orbiters, including the Mars Reconnaissance Orbiter, locked their instruments on the same region of sky that night.
This is 3I Atlas, this is Mars. 3I Atlas is about to swing by, and a fleet of camera-ready rovers and orbiters are standing by to snap some pictures.
For a few incredible hours, 3I Atlas became one of the most watched interstellar visitors in human history, seen simultaneously from both the Martian surface and orbit. But the real image that could finally end the size debate, that's coming from MRO's high-rise camera, capable of 30 kilometer per pixel resolution, more than 400 times sharper than Perseverance's NavCam. When that data drops, we'll finally know how big or small this mysterious visitor truly is. Ironically, just as the world needs answers most, NASA's official updates have gone dark, silenced by a government shutdown right in the middle of an interstellar flyby. For researchers eager to track what could be the most mysterious object ever spotted in our solar system, the timing couldn't be worse or more suspicious. Speculation is exploding online. Some scientists argue that 3I Atlas is simply a hyperactive comet, behaving in ways never seen before.
Well, it's something we've never seen before in solar system comets. But these are icy rocks that are in our backyard. And in fact, the question is whether similar rocks are made near other stars. And we might be up for surprises. In particular, there is a trajectory which is perfectly aligned with the plane of the planets. And that is something that cannot be explained just by observing or imaging it.
Others whisper more daring possibilities, that it could be a probe, a fragment of alien technology, or something far stranger.
Astrophysicist Avi Loeb has suggested the object has alien origins. He came on this show to say so a while back, even saying the object could be on a mission to release, quote, mini probes that could invade Earth.
While none of those theories have proof,
The blackout certainly isn't helping to calm anyone's imagination, but there's a new clue. On October 2nd, the Perseverance rover captured a faint slanted streak gliding across Mars's sky, a streak that didn't match the usual motion of stars or the planet's rotation. This wasn't a glitch or cosmic dust hit, it was real movement. And when the data was cross-checked, everything pointed toward 3I Atlas itself. Credit goes to Drew, a sharp-eyed observer whose viral post brought the discovery into focus. Early analyses suggest the object could be at least 5 kilometers wide, maybe more, but it doesn't have the blazing tail we expect from typical comets. Instead, it's shrouded in a vast, ghostly halo of ionized gas and dust. And then things got even wilder. Around September 25th, a coronal mass ejection, a violent burst from the sun, slammed directly into 3I Atlas. That impact may have triggered its strange glow and unexpected speed-up, now soaring past 60 kilometers per second and racing towards 68 kilometers per second as it nears its closest approach to the sun.
That solar blast may have energized or ionized the space around 3I Atlas, but surprisingly, follow-up images from September 27th and October 2nd showed no dramatic breakup, no sudden flare-up, and no shattered fragments drifting away, just a subtle, steady expansion of its glowing envelope, calm, almost serene. Some glow in front of the object towards the sun 10 times longer than it is wide. We don't see that often in comets. Usually the glow is behind, trailing the object away from the sun. That's exactly why NASA's coverage meant so much. In moments like this, when something so rare and fleeting sweeps through the solar system, every update matters. Fortunately, we're not entirely in the dark. The European Space Agency has stepped in with Mars Express and the ExoMars Trace Gas Orbiter, both locked on target during 3I Atlas's close approach. These spacecraft are gathering images, spectral data, and measurements of the gas and dust flow surrounding the visitor. Even the JUICE mission, originally bound for Jupiter, will get a chance to intercept the object as it races toward perihelion, the point closest to the Sun. The catch? Sun-Earth communication blackouts will delay much of that data. Still, when everything comes through, these combined observations could build the most complete picture yet of this mysterious interstellar traveler. And just to be clear, the now famous stripe seen by Perseverance wasn't evidence of alien engineering, and 3I Atlas isn't a colossal megastructure. It's far smaller, though still enigmatic. But how big is it really? That's the tricky part. Measuring a comet's true size isn't straightforward because what we actually see is its mix of its solid nucleus and its surrounding coma, a haze of gas and dust that flares outward as the sun's heat vaporizes its icy surface. This can make a tiny core look deceptively vast and brilliant. To pin down the truth, a Harvard team led by Richard Kluter, Avi Loeb, and Peter Varish analyzed observations of 3I Atlas from 227 observatories around the world, gathered between May 15th and September 23rd through the Minor Planet Center. By comparing the comet's actual motion with the path it would have taken if only gravity were at play, they hoped to untangle its real mass and size from the shimmering illusion of its coma. What the Harvard team uncovered was subtle but game-changing. They detected a tiny, persistent push acting on 3I Atlas about 15 meters per day squared, a telltale sign of outgassing, those faint jets of vaporized gas that nudge comets as sunlight heats their icy surface. But here's the twist. That acceleration is shockingly weak compared to how active 3I Atlas appears. That means this thing is massive, far too hefty to be easily shoved around by escaping gas. Based on the data, the researchers estimate its core weighs over 33 billion tons, stretching roughly 5 kilometers wide, not counting its sprawling coma. That's thousands of times heavier than any interstellar object we've seen before. Astrophysicist Avi Loeb points out that this makes 3I Atlas a major outlier. If the galaxy is filled with debris of all sizes, we should have encountered many smaller interstellar objects before stumbling upon one this large, but we haven't. Loeb even dares to ask the uncomfortable question: could something this dense and well-structured be technological? He highlights a few eyebrow-raising details: the trajectory's precision, the anomalous nickel detection without iron, and its unexpected mass as intriguing clues. NASA, on the other hand, is keeping both feet on the ground. Their stance is simple. 3I Atlas is almost certainly natural, not engineered. The visible coma, that glowing shroud of vaporized ice and dust, is a classic hallmark of a living, breathing comet. Still, not everyone's focused on what it is. Some are asking why it's here. Enter Dr. Suzanne Falsner, an astrophysicist with a bold theory. Maybe 3I Atlas isn't just a visitor. Maybe it's a planet-making seed. Picture this: a young solar system, its newborn star encircled by a swirling disk of dust and ice. Tiny grains collide and stick, forming pebbles, then boulders, then colossal planetesimals, the building blocks of worlds. It's a cosmic snowball effect, but there's a catch. These disks don't last long. Within a few million years, stellar winds sweep the gas away, halting the process before many worlds can form. That narrow time window has always puzzled astronomers. How could massive planets like Jupiter and Saturn possibly form before their disks evaporated? But what if the universe had a shortcut? Picture this. Instead of beginning from specks of dust, a fully formed interstellar object crashes into a young planetary disk, a ready-made core forged in another star system. Suddenly, instead of years of slow accretion, the disk has a solid nucleus around which gas and debris can instantly gather. In one move, that cosmic intruder kickstarts the birth of a new world. Dr. Suzanne Falsner's simulations breathe life into this theory. Her models show that massive stars with stronger gravity are far more efficient at capturing interstellar visitors than smaller ones. And when you look at the data, it fits. Gas giants tend to orbit bigger stars. The correlation between theory and reality is almost eerie. If she's right, interstellar objects like Oumuamua, Borisov, and 3I Atlas aren't just wanderers drifting through space. They could be the match that lights the fuse of planet formation, cosmic catalysts that spark the creation of entire worlds. Some may have seeded distant gas giants, while others could have played a role in our own solar system's formation billions of years ago. It's a daring idea, unproven, but deeply compelling. Studying these objects isn't easy. They appear suddenly, race across the sky, and vanish into the void before we can truly grasp them. But this time, with 3I Atlas, humanity finally has a head start. We spotted it early, and with next-generation telescopes and orbiters, we might finally move from speculation to revelation, uncovering the truth behind these mysterious messengers from beyond the stars.